This is Honors Geometry, section 14.2, Notes, trying to find area of parallelograms and triangles. First of all, what does area mean? Area means how many squares that are 1 unit by 1 unit we can fit inside of an object. That's what area means. So I think that we all know how to find the area of a rectangle. So like if I have a rectangle, let's say that is 4 high and 3 wide, like so. And you wanted to know what the area of that was. It means how many of these squares can we fit inside of this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or, if you prefer, the length is 3, we'll call that the base. The height is 4. 3 times 4 is 12. Now that's how you find the area of a rectangle, but that's also how you find the area of every parallelogram. Let me try to illustrate with a drawing. Let's say that I take a parallelogram that has the same base of 3. Let me make this a little bigger so we can see it better. Same base of 3, same height of 4, but let's say that this little fellow is slanty, like so. So that we have this parallelogram. Now what I'm suggesting is that this shape here has the exact same area as this rectangle on the left. I'm going to try to prove it to you. If I connect these like so, and I just break this apart so I can move it. If I take this, well, let me copy this. If I take this right here and I just shift it over here, see how that becomes a rectangle? Once again, this was over here. I lost my diagonal. I move it over here and it's just a rectangle. So long story short, it's probably too late for that, but to find the area of a parallelogram, you take the base times the height. Those are my marbles here. So let's check out some examples. To find the area of the following, so this first one, clearly a parallelogram. Keep in mind every rectangle is a parallelogram. To find the area of a parallelogram, it is the base times the height. The base is any side and the height is perpendicular to that side. How many square units can fit in this? Was 18 square meters can fit inside of this. Area of a parallelogram. Number 2, we have, let's discuss. The formula, once again, is area is base times height. This is of a parallelogram. Now the question is this the base or is this the base? Or is one of those the base and one of those the height? Well, technically the base can be either of those, but the height must be perpendicular to the base. The only thing that I see perpendicular here is this fella. So if that's actually the height, then the base that's perpendicular to that is the 11. So in this context, it makes the most sense for us to use the base of 11 and the height of 10.8. That product is 86.9, and the units is square yards. So in this case, the 10.8 wasn't even used. Number 3. We are told what the area is, and it wants to know what is that question mark. I'm going to call that question mark a B. Well, to find the area of a parallelogram, you take the base times the height. The base, we don't know. The area, we do know. The height, we know. Keep in mind that the height, which is 2, is perpendicular to the base. And in this case, this height isn't even in the picture, but it's still the height. No matter where you put it, it's perpendicular to the base. If you divide both sides by 2, you're going to get the base is 6 meters. Now let's discuss triangles. The area of a triangle is 1/2 the base times the height, and that is because if you put 2 triangles together, you're always going to get a parallelogram. So it stands to reason that a triangle has half the area of a parallelogram. Let's refresh our memory what an altitude is. An altitude is in a triangle is also the height. An altitude goes through a vertex to the opposite side forming a perpendicular. It's a segment that goes from the vertex to the opposite side forming a perpendicular. Now, just to remind you about this with some pictures, because some weird things can happen. We haven't talked about this in a while. Let's say this is the base. The height, which is an altitude, is going to be perpendicular to that base and go through a vertex. This is the height. It is possible that your height is inside the triangle like it was here. It's possible if you have a right triangle, and this is the base, that the height would be on the circle, or sorry, on the triangle. And it's also possible if you have an obtuse triangle that your height isn't in your triangle or on your triangle, but it's on the outside. So when something like this happens, we have to make an auxiliary line that's extending something that's currently there. So the height would then be here. Just want to remind you that the altitude of a triangle, the height, can be inside the triangle, on the triangle, or outside the triangle. See if we can find the area of this. We got 3 numbers. Can't use all 3 because the area is 1/2 base times height. Base and height are perpendicular. So we're going to use a base here of 6 and a height of 4.7. So it's 1/2 of 6 times 4.7. 1/2 of 6 is 3. 3 times 14.7 using a calculator is 14.1 square yards. Number 5, we got all kinds of numbers on this one. We just can't randomly choose the numbers. The base and the height are perpendicular to each other. So we can see this perpendicular symbol here. So 7 must be the base, and 5.4 then, which is perpendicular, must be the height. So the area is 1/2 of 7 times 5.4. Using a calculator, that's 9.45. The units of square meters. Number 6. Oh, we don't know the height. That's what we're trying to find. We know the area. Area is 1/2 base times height. Do we know the area? Yep, it's 35. Do we know the base? Well, if we're trying to find this height, then the base has to be what's perpendicular to it. So that would be the 11.3. And we don't know the height. That's what we're trying to find. 1/2 of 11.3 is 5.65. If you divide both sides by 5.65, so in other words, you're dividing 35 by that, you're going to get 6.19er. The unis we are using here for the height would be meters. So the height is 6.19 meters. On the flip side, you should take an opportunity to go back in your notes and review special right triangles, the Pythagorean theorem and your trig functions, because you might have to use those for this. For example, number 7, this is a 30, 60, 90. 10, which is opposite of 90 and a 30, 60, 90, we said that was 2 times the short leg. We said opposite 30 was the short leg, and opposite 60 was the short leg times the square root of 3. Well, if I solve this little equation, if I divide both sides by 2, I'm going to get the short leg is 5, which makes the short leg times the square root of 3, 5 square roots of 3. We can call this the base, this red thing the base, and this blue thing the height, or you can do it the opposite way. It doesn't matter. Potato, potato. Area is 1/2 base times height. We're saying the base and height are 5 and 5 square roots of 3. 5 times 5 is 25. 25 cut in half is 12.5. Let's just leave the square root of 3 in there and let's not round it. So that's a review of a 30, 60, 90, a 45, 45, 90. If you recall, we got 2 short legs, and the hypotenuse is the short leg times the square root of 2. Number 8, well, let's see. Since we got this perpendicular here, we'll call that the height, which must mean this here is the base. This base would be 5 plus 15, which is 20. So we know that the area of this fella, this parallelogram, and it's a parallelogram. I apologize. I mean, this really should have markings on it. So just assume for the time being, if something appears to be a parallelogram, it is. You shouldn't have to assume, but apparently I did a bad job on this picture, minimally. Maximally, I did bad job on many pictures. Area is base times height. We know the base is 20. Uh-oh, we don't know the height. If you look at this triangle right here, it's a right triangle. So you could use the Pythagorean theorem for this, or if you recognize it's a Pythagorean triple, this is a 5, 12, 13 right triangle, which makes the height 12. If you don't know your Pythagorean triples, it's fine. It's not required that you know them. So just use the Pythagorean theorem and you would get plus or minus 12. For us, lengths of segments are always going to be positive. Number 9. This is interesting. We have an angle that's 61 degrees, and we have a side that is 19, and we have the perpendicular side we don't know. Let's call this the base, and let's call this the height. We know the area of a triangle is 1/2 base times the height. We don't know the area. We don't know the base. And we know the height's 19. Well, how do we find this base? Well, we're going to use trig. Start with your acute angle. We have the opposite leg, which would be 19, and we have the adjacent leg, which would be B. That is tangent. Tangent of 61 degrees is the opposite leg over the adjacent leg. To solve this, we want to get B by itself. We want to get it off of the fraction first. We're going to multiply both sides by B and get B times tangent of 61 degrees equals 19. To get B by itself, we would divide both sides by tangent of 61 and get B is 19 divided by tangent of 61 degrees. Put that in your calculator, make sure that you're in degree mode. And I believe that you will find to 2 decimal places, this is 10.53. Once you know what the base is, you can put it into the formula, chuck this thing in your calculator, and I believe you're going to get 100.035. We weren't told the unit, so we just say generically square units. One last problem. This one, could be pain-inducing. You can tell that because it says such horrors as bring the pain, which gives me the shakes just thinking about it. This is a parallelogram. We're assuming that, once again, I did a bad job with the picture. These pictures need some things added to them. Assume it's a parallelogram if it looks like one. Although you shouldn't do that in the future, but I'm giving you permission for these notes and this homework. The area of a parallelogram is base times height. Our base, we'll say, is x plus 2. Our height, we'll say, is x minus 4. Remember, the base and the height are perpendicular to each other. Oh, and we know what the area is. It's 16. So I could put that in for area. My apologies for that. The directions aren't here for this, which is poor. The directions for this should be to find the value of x. To do this, we're going to have to multiply the stuff out on the right, the two binomials, then put the 16 over with it so all the terms are on one side equal to 0, and then we're going to have to factor it. So let's do that. X times x is x squared. X times a minus 4 is a minus 4x. 2 times x is a plus 2x. 2 times a minus 4 is a negative 8. So we get 16 is x squared minus 2x minus 8. If we move the 16 over to the right, we would be subtracting it from both sides. We would get x squared minus 2x minus 24. If the lead coefficient is 1 for a trinomial like this is, we can factor this right into two binomials. We need two things that multiply to get negative 24, and those same two things add to get negative 2. Negative 6 and plus 4 work for that. Once you have it factored, and for most folks, factoring is the hardest part of this, we set each factor equal to 0, and we solve those because we could have, apparently, two answers for this. So it looks like the answer could be 6 or negative 4. So how do we decide which one is going to work? If we put a 6 in for this, that would be 6 plus 2, which is 8. That seems okay. Put a 6 in for this, we get 6 minus 4, which is 2. That seems okay. If we try to put this negative 4 in, negative 4 plus 2 is negative 2. That doesn't make sense. Here, negative 4 minus 4 is a negative 8. We're not going to have lengths of sides that are negative. So the answer, this one here doesn't work. This one here does work. So x equals 6 centimeters. That concludes these notes. 14.2. Please do the homework that accompanies this, and I hope you have a fantastic day.